This is the next part of a code walkthrough for the example file Array1DExamples.java. Now, we said that this was a rather lengthy file and that it would be more effectively demonstrated by breaking it up into pieces. So that's what we're doing here. We've already examined the code above this point, so what we're going to do is we're going to set a breakpoint right here on this line, and just for grins I'm going to compile this again, and then I'll hit the debug icon and we're going to scream through all the code that we've already examined, leaving us at this point to start out. So again, here on the left in the debugger window is all of the data that was established in the code prior to this point. Now we're going to set up a new double array of size 5, and if we expand this down here we'll see that it's initialized to 0.0 by default. And then we'll do a number of standard operations upon this array. So for starters, let's show how to print the contents of an array. And I won't belabor this point too much, but in all the examples that follow, the loops are going to have the same basic pattern. We're going to have a for loop, and we're going to iterate from I equals 0, and an array always knows its length with this length parameter. So this array is of length 5. So we're going to loop from I equals 0 to I less than 5. So in other words, from 0 to 4. And on each pass through this loop, for all these examples, we're just going to do something with the ith element of this array. This is a generic expression for any particular element of the array for a specific loop index. So we're going to be seeing this pattern over and over and over again. So here we're going to print out all the elements of this array on separate lines. So we'll just cycle through this and we can see all 5 lines of the array displayed here. Next, let's show how to do the same thing except keeping everything on the same line. The only difference here is that instead of using println to put each element on a separate line, now we're using print, which keeps the output on the same line. The only thing different now is that we have to add this space after we print each element. But we'll cycle through this 5 times, and you can see that this is our output, and it's all remaining on the same line. We print out 1 element and a space each time for all of our 5 elements. And then at the end, we'll probably need a new line print to kick this down to the next line, and then 1 more for good spacing. Now, by default, this array is initialized to 0.0 for floating point types. Let's show how we can initialize that to some other value. Again, we go through a for loop, and then inside the loop, we set each array element equal to the same constant value. So in this case, 100. And then we're going to print out the loop index and the array element of each one, just to show that we're doing what we think we are. So we'll go through this loop and notice that over here in the debugger, the elements that are changing are going to appear in red, but when we're running a program, we can't necessarily see this in the debugger, so that's why we need some program output to echo what's going on internally. But we'll continue cycling through this, and the 0th element, the 1st element, the 2nd element, the 3 element, and the 4 element all printed out. We'll print a blank line to space out our output a little bit. So let's say then that instead of a constant value, we wanted to set this to some algorithmic value. For example, we want to set the values equal to 10, 10.2, 10.4, etc. No problem. If we can express that relationship in an equation, we can evaluate this right-hand side for each value of I, and then set this double value equal to this array element. So we'll go through the loop, and we're just initializing to different values and echoing out, as we did before, the 5 elements of this array set to non-constant values. Now we're going to ignore this chunk of code right here. We'll re-enable that in the follow-on video for purposes that we'll discuss there. But next we want to show how to initialize the values of an array from the command line. So again, we'll just repeat our for loop, and this time we're going to set each array element equal to a double value that we read in from the command line using our utils file. So here's our prompt, and this is using the scanner mode, and we're going to set each of these values to whatever we read, and again echo them out. So I'm going to be jumping back and forth between the debug and the command window, and I'm going to use these specific values right here to sync up to what you may have seen in the lecture materials. So let's start stepping through this. Here's the first value. We'll set this equal to 34.5, and we'll read that and print it out. And I'm going to expand this again, and then we'll come around and read the second value. We'll set that to 56.7. We'll update the value, come back around again after echoing it. Next value, we'll use 29.3, and we'll echo that out. Next value will be 42.1. We'll step through on this and prompt for the last value, which will be 56.8, and that should finish up our array. And we'll expand this, and so here are the 5 values we read in, and they've been initialized in the array. And the only bad thing here perhaps is that we've got the prompts and the outputs interspersed with each other, but I think you can see that it would be easy enough to separate this into 2 for loops if we didn't want that. So next, let's show how to sum an array. We set a initial sum equal to 0, and we set that before and outside of the for loop. And this data type of this sum needs to be the same as the data type of the array we're summing. So our array is of type double. So this sum is of type double, and we'll go through our array again with the same standard for looping pattern 5 times, and we'll keep adding up the value to this sum variable. We'll just keep adding on each array element. So as we see here on the left, this sum is going to keep growing, and we will print it out. Now notice something here. This value here is the raw sum, this one right here. This is exactly what is stored in memory. And notice that because of the inherent numerical representation issues of floating point numbers, we've got a whole bunch of residual numerical crap here. We might want to control the appearance of this to 1 decimal place, so we'll just use a format specifier on the same quantity, and we'll print out the raw value and the truncated value. So this looks a little more reasonable to the reader. Okay, the next operation will be averaging, and the same thing applies. We've got a running total. We're just going to sum everything up. The only difference is that now, after we're done, we're simply going to divide that total by the total size of the array, which is 5. Everything else is the same as for summing. So we'll kind of jump through this a little quickly, and we should have the same sum as before, the total, and we'll divide that to get an average of about 43.9. But we're going to again apply some formatting to this average. So this is the raw value, and this is the formatted output, 43.9, using a format specifier. In this next example, we're going to demonstrate finding the maximum and minimum values and indices of an array. So we're going to start out by assuming that the max and min values of some array, and we're using, looks like array name, we're going to assume that the maximum and minimum values are both located at the 0 index, which we know isn't true, but we'll loop through this array 5 times. And for each iteration, we're going to check each array element against the previous low or high watermark. If that value is less than the previous minimum or greater than the previous maximum, we're going to save not the maximum or minimum value itself, but rather the index at where that occurs. So let's go through this a little quickly. And I think we should agree that the minimum is going to be 29.3 at index 2, and the maximum is going to be 56.8 at the 4th element. So we're going to keep stepping through this. And when we get done, we know where the max and min indices are, so we can print out that index and the value that resides at that element of the array, giving us these results, which are in fact the minimum and the maximum of this array. Okay, we're going to stop right there and continue on with the next continuation code walkthrough for the remainder of this file.